Hi folks, today we're going to be talking about percentiles and how you encounter them in your daily lives. So, you've probably heard about taking a test and scoring in the 80th or 90th percentile, or a child having a height in the 75th percentile. What does that actually mean? Well, the kth percentile is actually a data value such that approximately k% of the observations are at or below this value, and the rest of the observation, that other percentage, 100 minus k%, are above that value. And to put this in perspective, we've actually encountered this before. When we refer to the median, you have 50% of the observations that are below that value and 50% above, which we could write as 100 minus 50, above that value. So we have encountered this type of formula before. Now we're just getting a little more abstract. So without further ado, let's take a look at how do we find the location of the kth percentile. So the way we're going to locate that is, if you're talking in the kth percentile, you're going to take k over 100, which is basically turning your percent into a decimal, and times that quantity n plus 1. And we've actually seen this formula before in some regards. Remember, the median is technically the 50th percentile. So when we look at that formula, it's 1/2 n plus 1. But another way we could write it is just getting the denominator of 100. That's 50 over 100 times that quantity n plus 1. So technically, we've been dealing with a percentile formula all along, just a simplified version. So yes, this does correspond directly with that location of a percentile. Now, a little warning, we're trying to have these two coincide, but if you actually look in the literature, there are some other definitions on how to find the location of percentiles. So you might have, for example, it'd be k over 100 times n. Not to say it's right or wrong, I'm just trying to have it where things coincide with how we defined the location of the median and the median definition. So those two things are exactly the same. So moving forward, let's take a look at this example. So we have a small sample of students in a psychology class, and we're doing that IQ test, and here's the results in the stem plot below. So if we were to try and find the 80th percentile of the sample, what we actually need to take a look at is, first off, what does the stem plot values represent? Remember, the leaves are the number of people occurring here. So for example, where you see a 1 next to that 7 up there, that's technically 71. So the first three data values are 71, 71, 79. And you could keep on going forward, 84, 85, 85, 85, 88, 88, 88. There's nothing in the 90 range to 99, so then we go to 104, and then you have 4 of those, and so on and so forth. So you can count all of them, and you'll immediately see that you have 23 observations. So plugging into our location for the percentile formula, you would get 23. So with the 23 observations, that goes in for n. Since you're dealing with the 80th percentile, that would be your k value. And with that, we can plug it into our formula, and we get 19.2. So what does that mean? Well, that means that our 80th percentile occurs between the 19th and the 20th observations. So we need to locate our 19th and 20th. Well, if there's 23, we can just kind of count backwards. 23, 22, 21, 20, and then here's 19. So we have these two values, 125 and 126. So with those two, we want to go. Now, usually with median, we always wanted to go halfway, but notice this is 19.2, so we want to go 2/10 of the way. Well, 2/10 of the way between 125 and 126 would be 125.2, and that will actually be our final answer. So for our 80th percentile, we actually end up with our answer being 125.2. Now, it can be a little bit more tricky when you have numbers that aren't just a distance of 1 apart. Like 125 and 126, the distance between those is just 1 apart. So how do we generalize that formula for the other scenarios? Well, there's actually an easy way to do it. And so it'll be kind of wordy, but once we see what's happening, it'll make a little more sense. So if we have the kth percentile being at a number besides 0 after the decimal point, so like just before we had that 19.2, for example, those 2/10 is what we'd be focusing on there. So if you're dealing with that and you have an ascending list of observations, how do we actually find the values? Well, we're going to let D represent that decimal. So as I mentioned before, we had 19.2. The 0.2 would represent D in that case. And if you're looking at the non-zero numbers to the right of the decimal point of n and n plus 1, let's say it's a sub n and a sub n plus 1 are the two values that it's actually in between, respectively. So if it's an ascending list, it's in between those two numbers. The way we can actually find our percentile is you're going to start with an, just like we started with 125 a second ago. And then we're going to add a decimal. So in our case, it was 0.2 times the distance between the a sub n plus 1 and a sub n. And the way you find the distance between is just subtract those two numbers. So 126 and 125 is what we had before, and we subtracted those two, we had 1. So technically that formula matched up with the 125 plus 0.2 times 126 minus 125 when we're taking that quantity of that last piece. So let's try another example and see how this works out. So same IQ test scores, so same number of values, but we're going to look for the 31st percentile. So hopefully we'll have some different things going on here. So with once again, we have number of observations is going to be 23. So when we plug that in for n and our k value is now 31, we're going to get 31 over 100 times the quantity 23 plus 1, which is 24. That simplifies to 7.44. So now we have the decimal is going to be 44 hundredths. We'll keep that in mind, keep that aside. But so notice it's between the 7th and 8th observation. So if we count it out, we go 1, 2, 3, 4, 5, 6, 7, and then 8. So 85 and 88 seem to be our numbers. So what that means is we're going to look for 44 hundredths of the way between 85 and 88. Okay? So the way we do that is we start with 85, and then we're going to add 0.44 times the difference of 88 and 85. So what you end up getting is we had our 85 plus 0.44 and times that quantity, 88 minus 85. At the end of the day, this finishes us off with 86 and 32 hundredths. So you can see how this formula is at work. Please try and work with it on your own, and let me know if you encounter any difficulties along the way.